You guys have known me for a while. I joined QuickLogic in 2006, where I came from Broadcom. And at the time, we had this vision of taking programmable logic and moving it into the mobile space. So I was actually Brian's predecessor running sales and marketing. And in 2009, I became the president. And when I became president, engineering and operations and sales and marketing all reported to me. And I thought that we were really on the right track, but we needed a refinement. And that was that QuickLogic had to have a goal. We just couldn't go to the market with general purpose programmable logic for the mobile market. What we said is our goal is to come up with application solutions that enhance the end user experience. And by end user, I mean everybody here in this audience. So we put together a number of strategic initiatives back right before I became the CEO to make this a reality. The first initiative was to become SoC agnostic. And what I mean by that is, as you will see, QuickLogic always attaches to a processor. So we need to be processor agnostic, and that will really expand our platform capability and to serve the available market. With that, we also said, initially when we started this venture, we said, we're going to go after the top mobile OEMs in the world. But since we're attached to application processor companies, we need to partner with the application processor people. And so with that, you'll see that we've actually worked with a number of people and become part of their ecosystem and part of their reference designs. Probably the most significant thing that I did was take Dr. Sachs, who when I joined, he had a dual role. He was the VP of engineering as well as the CTO. And what struck me about that is, as the VP of engineering, he was always working on the today, getting things out for today's customer. And what we were missing was this vision and this roadmap that would take us at QuickLogic into the future. So 3 years ago, I went to the board of directors and I said, we need to do two things. One is we need to increase our R&D budget radically. So at the time, we were spending 25% of sales. In 2011, my first year as CEO, we spent 45% of revenue on R&D. And we did that through 2012 and 2013. And what we're here to talk about today is what are the fruits of those efforts of that spending. Part of that was actually to staff an entire office of the CTO. Not have one guy responsible for the roadmap, but put a bank of talent around him, which includes software, hardware architects, as well as strategic marketing people like Andy that can really see into the future and, more importantly, go out to the market and test what does the market need. And in fact, Dr. Sachs and his team, mostly Andy and Tim, did that, and you'll hear the results of those efforts. So what have been our scorecard up till now? Well, up till now, as I said, the application processor is always what we connect to, and we think in terms of subsystems. So in the memory subsystem, we had very good success. On the inside, you can see the people that we have partnered with on the application processor side, and on the outside, you can see the customers we actually penetrated. So in this first segment, in this storage segment, this is where we were driving the data card market, where we drove very good revenue in 2010 and into 2011. On the wireless subsystem, once again, the application processor people we work with inside and the customers we work outside. And if you've been following our press releases over the last year and a half, we've announced several big wins with Kyocera, where we've actually connected multiple radios to application processors with their PHS phones. Matter of fact, we have demos of those on the table in the back of the room. Probably the biggest success we've had this year has been in our display product. And here we've worked with several application processor guys. And while we've had several customers, obviously the big guy is Samsung. And in Q2, we announced that we were in this platform. This is a Samsung Tab 3 7.0. And I call it a platform, not a device, because there are many different variants of this, and this is what's driving QuickLogic's revenue right now. We had a very good Q2. We had up earnings announcement for Q3, and at the end of this month, we'll have an earnings call, and I urge you all to listen to the earnings call and see what we're doing going forward. Then in the I/O side, we've had a public announcement of our partnership with Texas Instruments, where we've actually been able to expand their SAM by connecting to various cameras, and we've had success there. But the one thing that kind of struck me, and Dr. Sachs' team bore this out, is in these three areas, storage, wireless, and display, QuickLogic's existing programmable logic technology, which, as you guys know, is called VIA-Link. It's an anti-fuse technology, one-time programmable, instant on. It is actually ideal for all of these applications where you're connecting an AP to a single point. But what we noticed is that the biggest market, for us anyway, the expansion where hardware differentiation and flexibility, which is what we bring to the party, really needs something different in the I/O space. And so what we did, and what Dr. Sachs and his team said, is we need to have a second programmable logic architecture, one that is in fact reconfigurable and not one-time programmable. And as we go through the presentation, you'll hear more about how that plays into the market we're going after. The second thing he did is, what markets can we go after that QuickLogic can really make a difference? So we had this mantra that we have to go after markets that are big enough to matter, it's still small enough where we can win, but most importantly, our crown jewels, namely our reconfigurable programmable logic, that makes a difference. And so with that, we've identified sensors as a new area of exploration for QuickLogic. So I know you guys have been following this in the media quite a bit. Obviously, sensors are everywhere. I think today the count is up into the tens for iPhones, and in cars it's probably 100, and sensors are going everywhere. Now, of course, the problem is all these sensors take power, and the more sensors you put, the issue is, well, how much are you going to load up the application processor? And you'll be hearing Brian talk more about that later. So this is my last slide, and I don't want to take away Brian's thunder, but what did this increased R&D effort, this spending 45% of revenue, what did that bring us? Well, on the smart connectivity side, in late 2012, we introduced ArcticLink 2 CX, which is by far the most complex chip that QuickLogic has ever introduced. The big introduction was ArcticLink 3 BX, and this is actually fueling our revenue growth this year and well into next year. And mid this year, we announced a follow-on product where we can actually intercept that people do want to put a light engine in these devices, and we've got a single chip solution for that with our VNDPO. And we have more roadmap that we'll talk about at another global press conference. But the real emphasis today is two areas. One is talk about our new silicon platform that's addressing smart connectivity. Secondly, announce our emergence into the ultra-low sensor hub market, and a second silicon platform that Brian will be talking about now. So 3 weeks from now will be my 7th anniversary of QuickLogic. It's hard to believe I've been here that long. And I can tell you from my heart, I have never been as excited about QuickLogic's future as I am now. And I'm really happy that we have the international press here to be the first people. Brian and I have been biting at the bit to talk about this outside these four walls, and you are the first people that we're talking about this new initiative. So thank you for coming.
Thanks, Andy. Good morning, everyone. So Andy's been here 7 years. I've been here 7 plus 10 years. I just celebrated my 17th anniversary at QuickLogic. And I echo the same sentiment. I have never been so excited to talk to technical press about what we're up to. And so I'm going to be introducing for the first time to you our ultra-low power sensor hub technology, why we're doing it, what it is, what it brings to the design community. So before I go into the details of the product, I'd like to kind of level set everybody on why we're doing this. So obviously one of the big trends in the market today is that consumers are buying smarter phones. Feature phones are somewhat of a dying market. Smartphones are taking over, not just in the mainstream economies around the world, but also in emerging markets. And if you look at the flagship phones that are being launched today by Samsung, by Motorola, by Fujitsu, and by Apple, they're starting to change the marketing so that they're actually marketing the sensors that are in the phones and what they can do for people. So Samsung has this great S Health app on the phone. You can use that to count steps and monitor some of your exercise activity. Google, Motorola, they're talking about how the Motorola X phone has sensors and devices in there that are aware of the surroundings of the phone and what you're doing with it. Fujitsu has the human-centric engine. They're talking about things in white papers where you can use your phone at night to monitor your breathing to see if you have possible sleep apnea. And of course, Apple with the iPhone 5S talked about a very specific processor that was later found to be NXP, the M7 processor that's used for sensor management and motion sensing applications. So you can see sensors and their capabilities are kind of taking the forefront of what these phones can do for us. That being said, smartphones could be a lot smarter than what they are today. And I'll give you some specific examples here as a user. So I have a Samsung phone and I have tried that S Health app. And it's pretty good for counting steps, plus or minus some percentage. But I was running with my family 2 weekends ago. And we have 2 kids. So when we ran out on the trail, I pushed the kids, and that meant my phone was in the stroller. And when we went back home, my wife pushed the stroller, and I actually had the phone in my hand and listening to music. So when I got back to my house, it actually said I did about half the distance I really ran. That's kind of disappointing from a calorie count point of view. So it could have been better. Good, but it could have been better. If we think about advertising, my wife likes to shop, of course, and once you go inside an indoor mall, you kind of lose track of where you are, right? And I think stores would love, and the malls would love, to be able to serve you coupons or ads or opportunities to spend your money based on where you are, because we tend to be more impulse buy, right? Oh, this is 50% off, go right in. And the fact that, like it or not, Google actually knows some of your interests based on your Gmail account words. If they have the ability to match interest with contextual information, they can actually give much more accurate serving of those ads to the consumer. Pretty interesting. Who knows about Waze, the application Waze? You've heard of that? So it's basically a crowdsourced application, and Google paid, I think, around $1 billion for that this year. So the whole concept of it is that anybody that has the application on their phone, while they're driving, they can update that certain things are happening on the road. Traffic, accidents, there's a policeman, watch out for the speed trap. So all of this information gets pushed back up to the cloud and then distributed back down to all of the people that have the application installed. And that concept is called crowdsourced applications. So that's great, but at least in California, when you're driving, you're not supposed to be doing anything on your phone at all, hands-free, right? And you can imagine there's a lot of applications that you probably have on your phone that you would like to have things done more automatically, more intelligently, so you don't have to physically engage with a phone. And just some ideas, you know, obviously weather is a good one. Not so much here, but you know, in the Midwest where there's a lot of sudden weather storms that come up that can cause a lot of issues, there's a lot of sensors in phones today that can enable that. And it would be nice to have the intelligence to go along with it. And I think we've all read about the earthquake in the Philippines, killed a lot of people, unfortunately. You know, there's devices that are USB sticks that have accelerometers in them. I think they cost around $50 each. And they're actually deploying those out into areas that are emerging markets that don't have all the infrastructure that a lot of our countries enjoy today. They plug those into fixed systems like a PC on the floor or on the desk. And when earthquakes happen, they can actually use the accelerometer data to know where the hot spots are for these earthquakes and where maybe to send first responders to help the victims. That's a pretty expensive proposition to send a $50 USB stick all over the place. But if you think about it, there's an accelerometer in every one of our smartphones. And when our smartphone is sitting on the desk, it's a fixed object. So if you can detect earthquakes from that, have that data be crowdsourced, so it's automatically sent back to servers and distributed to first responders, I think we would have probably maybe lower casualty rate in the future. And then lastly, still on the safety bit, I think everybody in this room can appreciate concern for our older generation and our younger generation. For the older generation, people get concerned if they've fallen and they can't get up and nobody's there to help. But even today, I think older generations have smartphones. So if you could use the data of the smartphone to know when they've fallen and they're down on the floor and they can't get up, maybe they should automatically send messages or call people. In fact, my grandmother about 3 weeks ago fell outside her house and a neighbor found her. But she has a smartphone, so there's no reason that it couldn't have automatically alerted the family. And the same thing for kids in cars. I don't care if my daughter, when she gets a license, is texting while she's in the passenger seat, but when she moves 3 feet to the left in this country or to the right in the UK, Japan, into the driver's seat, I want messaging disabled automatically. So all those use cases can be enabled through the sensors that are going into the phones these days. And it's not just motion sensors like accelerometer, magnetometer, gyro. These are the common sensors. But now in those flagship products, we're seeing things like environmental sensors for pressure and temperature and humidity. And all of that is very useful data that can be turned into something useful. And that's what this next slide talks about. Turning that sensor data into actual information. That's what application developers want. They don't want to be manipulating things at the bit level. They want APIs that extract out useful information so that they can focus more of their energy on making the application useful for people. So today, who knows about sensor fusion? Probably everybody has heard that term. Very common term. And in the context of smartphones today, that really means using the data from the accelerometer, the magnetometer, and the gyro, running that through some math equations and generating yaw, pitch, and roll. For pilots like Andy, he knows exactly what yaw, pitch, and roll are. So that's very useful for a good gaming experience, right? We want very smooth motion gaming, motion sensing. But there's a whole underdeveloped area around sensors, and that's context awareness. And context awareness is actually what can make those use cases I was talking about earlier a reality today. It brings more intelligence to the system. So just some examples. We talked about my wife shopping in a mall, right? Now my wife is shorter than I am, right? So it's not just about step count. If I count steps, the distance I travel is much further than hers. But knowing that distance is actually very important to serve ads if you think you're somebody's walking by a storefront, right? It's that extra bit of information, the extra context. Think about health awareness and fitness. My example of running with my kids. I would really like it to know that I'm pushing my kids in a stroller and I actually ran twice as far as I did. Or if I'm hiking in the mountains, I would like it to know that I've actually changed altitude because my calorie burn is higher when I change altitude. So the data is in the phones. It's a matter of taking the data and making it into useful information. And the algorithms that do that, the computations, the algorithms that basically bring that information to reality, those are viewed as differentiators by companies. Some large OEMs have groups, dedicated groups established to this whole sensor domain. And there's also an industry being set up now for people that are doing algorithms that focus strictly on sensor data and making that very useful from an application point of view. And that's why we've invited Sensor Platforms to be here today and why we've cultivated this partnership with them. So you can see where we're going with this, right? We're talking about context. So let's talk a little bit more about that. Our context as a human being changes several hundred times per day. And that may seem like a big number, but actually if you think about gigahertz application processors in a mobile phone, a smartphone, several hundred times a day event is actually nothing. It's a very, very small percentage of time. So there's really no reason why this gigahertz processor should be managing something that's only occurring several hundred times a day, right? But in order to really process always-on context awareness, meaning that it's always looking at the sensor data to detect context changes, in order to do that effectively, you really need to be able to manage sensors real time And that data is typically in the hertz domain, 50 to 100 hertz. Not very fast. You need to take that data, and then you need to run these algorithms on it, the computational bit, at very, very low power consumption. I'm talking 1 to 2% of the system battery. You also need to be able to interrupt the apps processor at the right time so that once you've computed all this, let the apps processor know so it can do what it needs to do with at the application level. And by the way, you can't give up high-speed motion sensing to get context. As consumers, we expect in the future we're going to be getting more capabilities, not less. So you need to be doing that yaw, pitch, roll, high-speed gaming, and adding context. That's what's going to make a difference for people. So just to set context, no pun intended, for power consumption, this is the research that Andy alluded to that our Office of the CTO went and conducted. They went out, we hired some market research experts, they brought in a nice process, and we went out and we talked to handset OEMs, SoC vendors, and sensor algorithm companies, and we talked about, okay, so they're interested in context because it's a differentiator, but what power level does it have to be at to be able to be commercialized? And they consistently said it has to be 1 to 2%. Otherwise, the consumer is going to reject it because then we're not getting our web browsing and our phone calls. So for the Motorola X phone that was just announced, 1 to 2% is 5 to 10 milliwatts. And the way you get that, they have an 8,000 milliwatt hour battery. A typical day of use is 16 hours. 1 to 2% of that, 5 to 10 milliwatts. That 5 to 10 milliwatts includes the sensor power, and it includes the computational power needed to detect all the context awareness. Okay? So let's plot this now. See what the market looks like today. On the x-axis, we have power consumption. Obviously, it's logarithmic scale. Or on the y-axis. On the x-axis, we have the flexibility to run context. So the safe zone that the OEMs were talking about was that 1 to 2% of battery for power, and it has to be flexible. Because context awareness is a very new space. It's not as well understood as the yaw, pitch, roll motion sensing. So there has to be some flexibility inherent in these solutions. So that's the box. Today, if you were to do all this on the application processor, it's going to consume way too much power. Obviously, you can see it's 2 orders of magnitude too high. Microcontroller-based sensor hubs, this is what people use today for motion sensing. It's adequate, yaw, pitch, and roll. If you think about the use cases for that, it's mostly when the display is on and the processor's on. So adding 10 milliwatts is not that big a deal from a percentage point of view. But if you talk about always-on context, where this phone is constantly monitoring the context around me, even when I'm not engaged, now you need to drop down into that 1% area for the compute. That's not possible with these guys because basically their approach is to run everything in software on some kind of processing element. There are ASSP-based sensor hubs. Those are basically purposed for the motion sensing. So things like the Wii controller. The only thing that really needs to do in its life is track its motion for the gaming. So power is low, functionality is optimized for that use case, but if you were to try to run always on context on that ASSP, it wouldn't work because it doesn't have any flexibility. So you can see today there are really no solutions that fit in that safe zone. And that's exactly why, as Andy mentioned earlier, we wanted to look at markets that were big, yet small enough to win, and played to the strength of our crown jewels. Now, our crown jewels is programmable logic. That means there is inherent flexibility in that if we make that reconfigurable. So the hypothesis that Dr. Sachs and the Office of the CTO came up with was that if we have a programmable device that's supplemented by software, not all software, supplemented by software, then you can squash the power consumption because you're doing a hybrid approach of software and hardware. And it still has flexibility so that as this market changes and new algorithms come out, you can adapt to those changes with the flexibility. Okay? So that's the thinking that went into this architecture. So on this slide, you see the block diagram. There's the application processor on the upper left. Obviously, all these devices have an apps processor, and we're a companion to that. Our device has a communication manager, a flexible fusion engine, and a sensor manager. The communication manager provides that optimized channel to communicate information back up to the apps processor when it needs to, not all the time. It's a very low power interface. It has some smart FIFO technology, so you can manage FIFO overrun and interrupt latency with the apps processor. This is the exciting bit though. Flexible Fusion Engine. This core and part of the software chain that we have involved to program that is patent pending. This uses our programmable logic technology, and it uses a finite state machine that's microcoded and a CISC-based ALU to do all of these math functions that are involved in these sensor algorithms today. And this was developed from the ground up by QuickLogic. It's not licensed from anybody, through the office of the CTO, and it's purpose built for these types of applications. Okay? What we can do with this FFE is we can run the math that's involved in context awareness, context change detectors, and we can still do the things like motion sensing that are required for these applications. And then the sensor manager is also a microcoded state machine. It can be set up by the apps processor to go out and sample all of these different sensors at predefined intervals, take the timestamps, log all that information, and then at the right time it can get it back to the FFE for its processing and computation before we alert the apps processor. The FFE state machine and the sensor manager state machine are different. So you can set up one, put the other one to sleep, and hand off. So you get really optimized power consumption. Okay? So this is the architecture of our ultra-low power sensor hub. Now we're going to get to how you would actually use that in a system. So from a power point of view, what do we say? We said 1 to 2%. So if we plot 1 to 2% on this, this leftmost stack is a microcontroller-based sensor hub today with the accelerometer, the mag, and the gyro. And you can see that this microcontroller alone consumes all of the power budget. Not going to work for always on context. With our device, right here, 1/30th the power of a microcontroller-based sensor hub, we can now squash that entire power down into the 2% range. And when the next generation gyros come out, which have the power of the gyro, now we get closer to that 1% level. So we're well within that range that's required by the market to enable always-on context awareness. The other thing to think about here too is that at 1/30th, this is not the kind of power consumption you can get to by just going to the next node of a microcontroller. This is fundamentally different how we approach the problem and why we've come out to market with such a huge distance between us and any other architecture that's out there today. So, where does that fit in the roadmap? Andy showed you this slide. What we're unveiling today are 2 new platform families. The Smart Connectivity platform family is PolarPro 3. The Ultra Low Power Sensor Hub platform family is ArcticLink 3 S1, S for sensors. Both of these families use the new programmable logic that we designed from the ground up. It's reconfigurable and purposed for the mobile space, and it's the foundation that we've used to create this ultra-low power sensor hub technology. So where does this fit in the whole spectrum of solutions at QuickLogic? We've talked many times to you about customer-specific standard product. This is where we have staff of engineers. They'll work with an OEM, understand the requirements of that OEM, and do the programmable logic and software driver design so that we can deliver a solution to that customer. And that typically is on the order of weeks. When this is done, this is one design, one customer. We have reference designs, some of which you'll see at the break. These are known good starting points. Great demonstration vehicles for customers, lets them think how we could possibly be used in a system. And lastly, what we announced at the April Globalpress event in Santa Cruz, you remember Andy was in front of you, of many of you, we talked about catalog CSSP. Catalog CSSP is where we will do a design, programmable logic, software driver design, but we have the intention of selling that same design to many people. It opens up the market for people who want to take advantage of the technology but maybe don't have huge volumes. And from a business point of view, it allows us to amortize our development costs across multiple set of customers. So one design, one customer, starting points, one design, many customers. What I'm going to be talking to you about now are two examples of catalog CSSPs. So people that want this always-on context awareness can adopt these solutions straight away. The first is the always-on context-aware sensor hub. It uses the ArcticLink 3S1 platform that we just talked about. It's very low power consumption, we'll show you later, but 300 microwatts of compute power. This is how we get to that 1/30th. It's very small. It's, in fact, the smallest programmable sensor hub in the market today, 2 by 2.5, tiny. You could lose this on the floor. And it's flexible and reconfigurable. So we have that flexible fusion engine. We can use that so that we can do the context change, we can do motion sensing, and because it's now reconfigurable logic, we can actually repurpose that FFE at different times of the day. So if you have a phone and you want to download one algorithm while you're sleeping, and you want to download a different algorithm while you're awake, it can do that real time. And I think most importantly, what really makes this solution fly is the fact that we're working now with sensor platforms. They're experts in the sensor algorithm field. They have a library called Free Motion Library that's ported to this Flex Fusion architecture. And one of the key elements is the context change detector. What that means is that every time, remember that several hundred times a day, when something changes, it's going to know something changed. It can alert the application processor, classify that change in their software, and then that allows software developers to go off and do something different with that information, turning data into information, very low power consumption. We're very excited about this, actually. The second catalog CSS, or sorry, not the second, a little bit more on the sensor platform's Free Motion Library. So just to give you some idea of what we're talking about, context change, their library knows if you're shaking, rotating, translating the phone, how you're carrying it. Is it in front of you? And also, are you sitting, standing, walking, running? These are all useful pieces of information that can enable an entirely new set of applications at the application level. And then on their roadmap, they have things like transport. So you're in a car, maybe you can also detect if I'm pushing the stroller, so I can get accurate calorie counting. That'd be great. So I hope you guys get the picture of what we're able to deliver now in the combination of our architecture, the programmable logic, and sensor platforms IP. The second catalog CSSP is a multi-axis sensor data buffer solution. So let's say you're an OEM and you don't want to have the computation, the context change detection down at the device level. You don't need that. We can still manage all the sensors, gather that data, and buffer up 10 seconds of sensor data, and then alert the application processor that buffer is full, take the data, go back to sleep. Keep it asleep longer, longer battery life. Okay? So I just gave you examples of two catalog CSSPs, but as I said in the very beginning of the presentation, there are companies that actually have sensor teams dedicated to sensor research and algorithms. Sensor Platforms is obviously doing this, and they don't want to share their knowledge, their IP, with a company like QuickLogic. That's their crown jewel. So we have to have in place a tool chain that allows them to map their algorithms down into the silicon without us having any involvement. And we've set that up with this OEM tool development chain. So we have the board, so they can use our device. We have software in place that's an integral piece of how we can do patents around this whole architecture. They can take their ideas, their algorithms, and map it down to the architecture using the software tool. It allows them to design it, simulate it, and build it. And then along with that, we have the operating system drivers for Android. We have obviously an ecosystem under development, the first of which is the sensor platform. So if people want that good starting point of algorithms for the architecture, they have that option. And then lastly, we have application notes and function libraries. Most of the people that are dealing in this domain are experts in algorithms. So they're doing things, they're simulating things, and they may have a concept of, hey, I want to start with a pedometer, and I know how I need to add my secret sauce to this pedometer to make it more useful. So the app notes we have are really about those types of functions, pedometer, frequency analysis, things like that. Good starting points for these engineers so they can tweak from there. So let's go back to this slide. So the fact that we can do the compute at 300 microwatts of power, the fact that we have this runtime reconfigurability with the FFE engine and the programmable logic puts us squarely in this safe zone. It squashes the power and it still has the inherent flexibility needed by these OEMs. And just to take it back up to what Andy started this whole presentation with, this is a paradigm shift that we're enabling here. This is not a better microcontroller. This is not coming out with 10 ASSPs for different context awareness. This is rethinking the architecture from the ground up so that people can get that very low compute power that they need and the flexibility that they want. We're doing that with our platforms. We're announcing the 2 catalog CSSPs I mentioned, the ultra-low power sensor hub that has the context awareness, the multi-axis sensor data buffer, the 2 new families, PolarPro 3, ArcticLink 3S1, and all of that is enabled by the fact that we've actually added a second underlying programmable logic technology that is reprogrammable and very, very low power. That's the enabler for this entire use case that we're talking about today. So with that, and with context, we pose the question back to you. What do you think could be enabled if there was more intelligence and more context awareness in these phones today? Personally, I think it's endless, the types of applications that it can enable, provided it's at the right power.